everybody, it is Mike Levin on Saturday, February 12th, 2022. And I figured I'd catch a little bit of this wonderful light, get a quick video in as I'm going to pick up my kid. I'm more than halfway there, so I'll make this a short video of necessity. I'm sure most viewers will be relieved. I have some friends who are taking up Python now as part of taking up FreeCAD, as part of taking up 3D printing. So we got a 3D printer. We got a bigger, fancier one. For many years, we had the 3P mono price from Amazon, the one that Amazon sort of shovels you into for $300, and it's just the most wonderful thing for $300, and it served us well for several years, but we've upgraded. I'll give the details on what we have. I hardly even know the names right now. But the point is that my wife and her friend are into 3D printing, which is just totally awesome. And they started out on Fusion 360, which is an AutoCAD product, and yay for AutoCAD, still being around strong after all these years. But they went to the same pricing model as Adobe, the subscription annual pricing model, and a pretty steep one, $500 a year. So Fusion 360, at least the paid version without the limitations, is now very similar to the Adobe software, which I'm just sort of innately allergic to having to pay an annual graphic artists guild fee to use the tools of the trade. It's stupid. It's stupid in this day and age of free and open source software. However, across the total Adobe suite, not all those products exist in the free and open source world. Thankfully, CAD does. Not that Adobe is dominant in CAD. It's Autodesk. It's a bizarro thing, but Blender exists in the free and open source world, and I've actually tried to take that up personally for 3D modeling, but I realized that there's a big difference between CAD software and 3D modeling software. You're either designing for looks or you're designing for manufacture. So if you're designing for looks, you use Blender, you can do all kinds of wonderful movie stuff. If you're designing for 3D printers, it's better to use CAD software because it makes you pay attention to things like the interior width of things so that you're not printing solid chunks of plastic. Now, of course, the slicer part of the software can solve that, and there are bridges between the Blender world and the 3D CAD world. It's probably a lot further along than when I investigated, and of course the polish of Blender is like nothing else in the free and open source world, so it's worth it even just for the experience of a polished graphical user interface in FOSS, which is quite uncommon. So on the Adobe suite, of course, there is Inkscape and GIMP, which have both sort of established themselves very firmly as the Illustrator and Photoshop alternatives, respectively. I highly recommend them. They're some of the few things that are actually still on my Windows Start menu. I strip it down to almost nothing, but Blender and Inkscape always remain. I said Blender and Inkscape, it's Inkscape and GIMP always remain. Blender comes and goes because I'm not really a 3D modeling person. However, those are three dominant software packages in the free and open source software world that give you freedom from Adobe and now apparently Autodesk as well. So my wife is into Python, and I'm talking her and her friend through all these startup issues of Python, and the concept that, yeah, anything's possible, and the way you think to do it naturally is probably doable and perfectly valid. It's how people do things in the C programming language. And then we get into the whole discussions of the landscape of different languages and why Python is what it is and why it's become so popular, I want to say in recent years, but with a linear increase in popularity for the 30 years it's been out. It's just an unending uptake of this, language for its, wonderful attributes. And some of those attributes include secret built-in things that you have to be indoctrinated to, you have to be introduced to. So the primary example is enumerate. The enumerate function or keyword that can be used in all kinds of loops. So whenever you're stepping through items in a collection, so for item in items. So items is a list with a bunch of stuff in it. And so you can loop through it in Python with the word for, F-O-R, space item, I-T-E-M, space in, I-N, space items, I-T-E-M-S, colon. And then you indent under that 2 or 4 spaces usually. By convention, 4 spaces is liked. And all your indents after that point have to be a consistent indent. If you do the first indent in a loop 4 spaces, then the rest are 4 spaces. And then when you outdent again, you're no longer in the loop. It's a beautiful, intuitive syntax that all other languages, their users emulate, even though those indents have no meaning in most other languages. Developers, coders, programmers still do that anyway. So Python says, hey, why not just make that mean something and get rid of these other curly brackets that indicate code blocks? And that way there's so many less vertical lines of code because those curly brackets end up being on lines by themselves, and there's ambiguity about where you put them. So you get rid of all that ambiguity, all that extra vertical space by just saying the indents mean something. But anyway, I digress. The issue at hand is that if you are stepping through item in items, and on each iteration you have that item from the list. It steps through items and it grabs an item from the list. So you're holding a reference to that object in that iteration, in each iteration of that loop. Say you want to counter. Say for some reason you want to refer back to the next item up, the item that's coming up, not the one that you've iterated up to, but you're interested in looking ahead to the next one. Well, you have the items object, and you could drop a numeric index in there, 0 to get the first item, 1 to get the second item, and so on, because Python has a 0-based index, like so many languages. It's not the wrong decision, it's just the very techie programmer type decision. The first location in a list is often the location 0. So, for item in items, you're sitting on item. But if you only had what iteration you were up to as a numeric index, I'm on, the first loop, I'm on the second loop, I'm on the third loop, you could take that, say, third loop number 3, or 2 because of 0-based index, add 1 to it, and plug that in as a numeric, index on your original items list, and get the next item, the one you haven't iterated up to but is coming ahead. So in 3D software, this apparently is useful for, joining line segments. You need the beginning, the end of your current line segment, and the beginning of the next line segment, so that you can feed them to a function and join them together to make a continuous line out of line segments. So it's a perfect use for having to look ahead to the next coordinate in a list of coordinates, or the last one, depending. You can look ahead or look behind, depending on, which kind of model you want to use. And that was one of the more difficult things in this instruction, because unlike the Go language from Google, the new Go language, which is great for concurrency and performance and deployment and all kinds of other interesting things that were the scratch compile time. These are the itches that Google was scratching when they created the Go programming language that they make most of their back-end systems stuff in, and in fact probably the front-end stuff probably is all their systems these days. But whenever you're looping through items in a collection, the Go language automatically exposes the internal counter, which is always there anyway. There's no way something's stepping through items in a list without having somewhere internally for its own record keeping some, counter with a 0 value, then a 1 value, then a 2 value that goes one larger on each iteration of the loop. So in Python you have that too, but you got to use the enumerate keyword. You have to pop out a counter by saying for item in enumerate collections. So you have to be told. You don't just stumble across enumerate. When you have this problem, even just articulating that I need a counter, and then you're tempted to make a counter, say the C programming way, which is to, declare a variable and initialize it with a 0 value at the beginning, and then to add 1 to it through each iteration. And that's valid. However, it's unnecessary, because if you just wrap your collection inside the enumerate function, enumerate, E-N-U-M-E-R-A-T-E, enumerate, which if you only just do that, then you can say I, item in enumerate collections. Now the story gets deeper because list comprehensions come into the picture and that I variable. So these variable names are arbitrary. That's a very, very big tripping point when you say, okay, construct a loop where you say I, item in items, for I, item in items, colon. There's only a few things to explain. Why I, why comma, why item. Okay, in items, that kind of makes sense if you created the items list, but everything else is kind of arbitrary seeming. And you have to know that when you use the enumerate function around your collections in a for-in loop, by convention, the first variable name you give becomes the internal counter, is where the enumerate function plops the internal counter value. So now on the first loop you have a 0, on the second loop you have a 1, and it's all contained within the I variable. Why is that useful? Well, to look ahead to the next item up in the collection. If your items collection is called items with an S plural, you can put square brackets around it. If your counter reads 3, you're really on the 4th step of the loop, but your counter reads 3 because of a 0-based index. You can take that I, which contains the value 3, add 1, I plus 1, and plug I plus 1 into the square bracket numeric index location on any collection that goes to the right of a collection. So items, open square bracket, I plus 1, close square bracket, will get you the next item in the collection. So in this way, you can construct tuples that kind of look ahead at the beginning coordinate of the next line segment, so you can create a series of tuples that you need to do the join. Wonderful stuff. Okay, you'd think that's the end of the enumerate story. I learned something new today. I'm sure I knew it. These are the kinds of things you learn and then you just gloss over, not realizing the importance of the learning. There's something in Python called list comprehensions. It was borrowed from another language, I forget exactly which, but list comprehensions rock. They are loops with single line syntax that are very equivalent to how lists are written with square brackets around them. So basically you take your items list and you put square brackets around it. So it's a nested list. It's a list within a list. And then you can say X for X in between the two opening square brackets. So open square bracket, X for X in, next open square bracket, items, close square bracket, close square bracket. And that lets you do, stupid data tricks, stupid loop tricks, loops without loops that you have exposed the internal of your list. So X for X in items is kind of arbitrary. It could be, if your list was coordinates, which it was in this case where I thought this through, it was chords, it was a list. So chord for chord in chords. One coordinate for each coordinate in coordinates. So looking at it probably makes more sense than saying it out loud, but it lets you do things like, manipulations on the coordinate. If the coordinates are tuples and you wanted to grab the first number out of a, three, X, Y, Z, say it was 3 points in space, there's an X, Y, and Z coordinate, and you wanted just the X value, which was in the first position. Your X for X in, you would say X open square bracket 0 close square bracket, and it would grab the first item out of that tuple. And in that way you can create a list comprehension that returns all your X values, all your Y values, or all your Z values, right? So it's really, really simple. It's, list comprehensions and 3D coordinates are a match made in heaven. But say you now want to do this trick of look ahead to the next coordinate coming down the pike, and you're using a list comprehension. So it's X for X in coordinates, and you want the next coordinate in coordinates. So you can put the word enumerate around coordinates in a list comprehension. List comprehensions plus enumerate is a powerful combo. Now you have a numeric index which you can feed into coordinates. So you actually make reference to the full list. Even though you're doing X for X in coordinates, you can use that whole coordinates reference in with that first X, so long as you plug a numeric index in there. And if you plug a numeric index in there, which is one larger than the loop iteration you're on, you have the next item from the list, and then you can grab its X coordinate, all that kind of stuff that you need for FreeCAD in order to join line segments. Now the discovery, the thing I didn't know is that I rule, or that rule of the first arbitrary variable name becoming your internal counter, does not apply in list comprehensions. Instead, enumerate makes that first X return as a tuple. It converts it into a tuple. So if it already is a tuple, you've got a nested tuple. It returns a tuple that has two positions. The first position in the tuple, and for those who don't know, tuples are like short lists. They're like lists with a fixed number of locations, very memory efficient. Lists themselves in Python are dynamic and have a lot of memory overhead and take a longer time to process when you use lists for simple things. So when it's simple things, you use a tuple instead of a list, and it's a lot more memory efficient. It processes much faster. And so in this spirit, enumerate, instead of returning its internal counter value in the first variable used in a for loop, how it works outside of list comprehensions, it instead forces the list comprehension to return a series of tuples, one tuple for each item in your list. The tuple now contains the item in your list that you're asking for, plus the counter, plus the internal counter. So a tuple would look like open parentheses 0, 3D coordinate. The next tuple you receive would look like open parenthesis 1, 3D coordinate, close parenthesis, of course. Just missed my turn. Okay, well, anyhow, this is where I wrap up, because that pretty much makes my point. I'm still on a pretty early schedule, so I can correct myself, but I got to do it fast. And so there, you need to be taught about enumerate. You need to be taught about enumerate specifically in list comprehensions, and then you need all those tricks of popping values out of tuples in order to use it, and then reference back to the original list that you're iterating through inside of the list comprehension. These are not natural things. You definitely have to be indoctrinated. And so I'm going through that process with my wife and her friend Danielle, who are in this deeply engrossed in this process, and I was happy to be able to bring this knowledge to them, but I wanted to make this video while it was fresh on my mind. These things are rarely obvious or intuitive, and I really want to capture them and make a series of videos, one on each topic, for the new Pythonic ally, Pythonically.org and .com that I'm launching. So these are the videos that I'll organize into that site. So thanks for joining me. Hope to see you again soon, and don't forget to subscribe.